I'm Timothy Ajibola, popularly known as T-Square. I'm to treat an important topic in physics known as gravitational field. This topic is very, very important because it affects us. Gravitational field. What's a gravitational field? Gravitational field is a region of space under the influence of force of gravity. Again, gravitational field is a region of space under the influence of the force of gravity. And we have many scientists that contributed to the discovery of gravitational field. We have Galileo, we have Nicholas Copernicus, we have Isaac Newton. We also have the law, we also have Kepler. These are the people that contributed greatly and brilliantly to the extent of the force of gravity that made us to know that there are forces acting on the body in the gravitational field. That is why Sir Isaac Newton put forward a law under this aspect. What is the gravitational field? Is a region of space under the influence of force of gravity. So we have scientists that contributed to the discovery of the field. So one of them is Sir Isaac Newton, which contributed brilliantly that the world cannot even stop up to today. And he stated a law. We call it Newton's law of gravitational constant. We call it what? Newton's law of gravitational constant. And the law says the force of attraction between two bodies in a gravitational field. Again, force of attraction between two bodies in a gravitational field is directly proportional to the product of the masses and inversely proportional to the square of their distance apart. Again, the force of attraction between two bodies in a gravitational field is directly proportional to the product of masses and inversely proportional to the square of their distance apart. So this is what we meant by that law. We have a body. Let's call this one is capital letter M. That's the mass. The second body is small letter N. Now the distance between them is regarded as R. So according to Newton's law, the force of attraction between these two bodies in a gravitational field is directly proportional to the product of their masses and inversely proportional to the square of their distance apart. And it is expressed as F proportional to the M. So this M is the mass of the bigger body, while this one is the mass of the smaller body. And the force of attraction is also inversely proportional square of the distance apart. The distance is represented by REM. When you now put them together, you have M proportional to M over R squared. Now remove this. Now put constant of proportionality. You have F equals to GN over R squared. Now this F is it is the force of attraction in a gravitational field. While this is gravitational constant with value it has a constant value. Then this one is the mass of the bigger body. While this one is mass of the smaller body. While this R is the distance between the two bodies. So this is the formula to calculate the force of attraction in a gravitational field. Force of attraction in a gravitational field. Now the next one you need to know is what now? You need to know the Kepler's law. Kepler's law. What are Kepler's laws? Johann Kepler put forward 3 laws in this field. The first one is known as law of orbit, which states that the planet describes the eclipse about the sun as one focus. Again, planet describe the eclipse about the sun as one focus, which means the sun is at the center of the universe. Other heavenly body moves around the sun as their focus. So they move around the sun. So that's why it is the focus of every other planet. That's why the planet described in eclipse about the sun as well. One focus. That is the first law, and it's called law of orbit. The second law is what? Law of area. What is that? A line joining the planet and the sun sweep out equal area at equal time. The line joining the planet and the sun sweep out equal area at equal time. Supposing this is the sun, while this is the planet in its orbit, moving in its orbit. Now, there is a line joining them together like this. As this planet moves, the line also moves, and it will sweep out equal area at equal time. That is what we call Kepler's second law. It is called law of area. And the third law is what? Law of period. What that will be, and that will state that the square of the period of a satellite, the square of the period of a satellite is directly proportional to the what? To the cube of its distance from the sun. Again, the square of the period of a satellite is directly proportional to what? Cube of its distance from the sun. So a satellite, the square of the period of a satellite is always directly proportional to what? Cube of its distance from the sun. That is what we call law of period. We call it what? Law of. So these are the three laws of Johannes Kepler's to govern the motion of body and heavenly bodies about gravitational field and its contribution in gravitational field. Then another thing you need to know is what? Relationship between gravitational constant and acceleration due to what? Gravity. Again, relationship between gravitational constant and what? Acceleration due to what? Gravity. We know that gravitational constant is a constant value which is equal, be it on planet Earth or any other planet. It is equal, it is constant to all planets. While acceleration to gravity is not a constant value, it is a varying value which is not the same in all planets. For instance, that of planet Earth is different from that of planet Moon. So what from our formula we have F equals to GM M over RE squared. If you are doing that, you have to relate it to the planet Earth. So this F is what? Force of attraction between the body and the Earth. While this G is gravitational constant, while this G is the mass of the body, while GM is what? Mass of the Earth. While this R is the distance, radius of the Earth. Radius of the Earth. So F is equal to what? Ng. So this is under gravitational field, while this one is under mechanism, which is what? Mass times what? Acceleration due to what? Gravity. So this force and this force, if they are equal to each other, we are going to have G bigger M ME over what? RE squared. Don't forget this ME, mass of the Earth, must equal to what? Mg. So M cancel M. What we have here is what? G, which is the acceleration to gravity, is what? G ME over RE squared. So that is relationship between gravitational constant and acceleration due to what? Gravity. What is acceleration due to gravity? It is the acceleration processed by a body due to the Earth's attraction. Again, acceleration processed by a body due to the what? Earth's attraction. It is always greater at poles but less at the equator. Again, greater at poles. This G is greater at poles but less at the what? Equator. And this is the formula under field. It is the product of this and this divided by the what? Radius of the Earth. That is what we call. That is the formula to calculate acceleration due to what? Gravity. The next one you need to do is what? Gravitational potential. Gravitational potential. What is gravitational potential? This is the work done in bringing a unit body of mass from infinity to that point. Again, gravitational potential is the work done in bringing a unit mass of a substance from an infinity to that point. Check it. It is work done. So we denote it by what? V, which is what now? Work done. W over mass, a unit of mass. So this was first from my lab to know about that. So gravitational potential, sorry, Vg. Gravitational potential is what? Work done over mass. Work done is bringing a unit of mass from infinity to that point against the gravitational field. So that's why we call it, and it is always negative. Why is it negative? Because it is against the gravity. So it is work done over mass. Don't forget, under normal circumstances, work done is equal to what? Force times what? Distance. So you can also write it as what? Vg is equal to what? F times R over what? N. This is another formula to calculate gravitational potential difference. Gravitational potential difference. Another formula is what now change. You know that F from the first equation, which is what? GMM over R squared. So this formula is for F. So insert this into this equation. We are going to have F Vg. Instead of me to write this, what is the value? That was GMM over R squared. Then what do you have there? Times R over N. The next one is what? This cancels this. R cancels one R. Finally, we are going to have V is equal to what? Minus GM over R. Minus GM over R. So this is another formula to calculate gravitational potential. It is GM over R and negative sign. So this is gravitational potential, and gravitational potential is always what? Scalar quantity. I've told you in the scalar quantity that scalar quantities are quantity with only magnitude. Then the next one you need to know is what? Gravitational field intensity. Gravitational field intensity. It is the ratio of force to the what? Mass. Ratio of force to the mass. So we full stop. Now, field intensity is what? F over N. F over N. Gravitational field intensity is also known as acceleration due to gravity because both of them are ratio of force to the mass. Ratio of force to mass, and it is a vector quantity. It is a what? Vector quantity, and the formula is what? Ig is equal to what? F over N. So if F is in Newton, mass is in kg. So the unit of Ig, which is what? Gravitational field intensity is what? Newton per kg. Newton per kg. Newton per kg. And don't forget, recall that F is equal to this. So put this into the equation level. Ig is equal to what? Bigger G mm over R squared times 1 over N. Cancel, cancel. So Ig is equal to what? Gm over R squared. These are not formula to calculate gravitational field intensity. Gravitational field intensity. Now don't forget to say what? Vector quantity. The next thing you need to know the what we call escape velocity. Escape velocity. What is escape velocity? Can you see the plane? The plane has not dropped back to the towards the center of the earth because they are at a region where the gravitational force or pull there is zero or is not even affecting them. So what is escape velocity? Before the plane can move or take off, it has to acquire a certain velocity to escape from the pool. So that velocity it acquired is called escape velocity. That is the minimum velocity acquired by a body to surpass the gravitational influence. The minimum velocity acquired by a body to surpass the gravitational influence or the work done by a body to leave the field of astronomical bodies. That is what we call escape velocity. And in that case, you now say the work done by the body must equal to what? Kinetic energy of the body, which is what? mv squared. The work done is equal to kinetic energy of the body. Work done is always what? Force times distance must equal to what? 1 over 2 mv squared. Now in this case, force is what? We have what? Gm over R squared times R equals 1 over 2 mv squared. In this case, m cancel what? M. R cancel R. We have what? Gm over R equals what? V squared over 2. We now cross multiply. We have what? 2 Gm over r equal to what? V square. Now square root both side. We have what? V square is equal to what? 2gm over r. Sorry, ordinary V. So this is the first version to calculate escape velocity. Then we also have another version to calculate escape velocity. From radius of the earth, we have one now. G is equal to what? Gm over r squared. From here, we also have another formula. So when you make Gm the same formula, we have Gm equals to what now? Gr squared. Gr squared. Now put this as Gm in this equation. V is equal to what? Square root of 2. Instead of it to write Gm, the value is what? Gr squared over r. R cancels r. So V is equal to what? We have something like this. 2gr. This is another formula to calculate escape velocity. Escape, there are two versions of formula. The first formula is what? In terms of gravitational constant, and the second one is what? In terms of acceleration due to what? Gravity. Don't forget, escape velocity is what? It is the velocity acquired by a body to surpass the gravitational influence. Another thing you have to know is what? What we call parking orbits. Parking orbits. What is a parking orbit? Parking orbit. A parking orbit is the orbit at which the period of a satellite rotating about its own axis is exactly period of the Earth. Again, a parking orbit is the orbit at which a satellite rotating about its own axis, the period of the satellite rotating about its own axis is equal to the period of the Earth. And when a satellite is at parking orbit or launched to the parking orbit, then TV station or TV programs can be shown continuously. That is why we have 24 hours programs on our TV stations. Before, in the olden days, you don't have something like this. Programs start from 5 and ends 10 o'clock, 10 p.m. But now, we have 24 hours program on TV show because of this technology involvement. So, parking orbit, when a satellite is at the parking orbit, the television program can be shown continuously, even 24 hours. So that's parking orbit. So parking orbit is what? Orbit at which the period of the satellite is rotating about its own axis is exactly what? The period of the Earth. So example of parking orbit is what? We have relay satellite. That is what I just explained now. Relay satellite in its parking orbit for TV transmission. We also have synchronous satellite for war and spy for weather and climate change like that. So these are examples of what? Parking orbit. Another thing you must note about this field is what? Weightlessness. It is a feeling of no weight, or when the total or the total force acting on the body is zero. That is when you feel weightlessness. So weightlessness occurs when there is no weight, or you feel no weight, or the total force on the body is zero. That is what we know or term weightlessness. So we can look into some example and solve question in. So let's solve question number 1 now. Now the first question is what? The man calculates the force of attraction between two bodies of masses 10 raised to power 3 kg and 10 raised to power 8 kg. If the body are separated at a distance a distance 2 meters apart. So this is a question that we should solve. They said if calculate the force of gravity, the force of attraction between two bodies of masses 10 raised by 3 and 10 raised by what? 10 raised by 8 kg. Full stop. If the bodies are separated, at a distance of 2 meters. So we recall the part of the formula. F is equal to what? GML over R squared. GML over R squared. The first thing you have to know, if you don't know the parameters very well, you'll be able to work. So you must understand the question and the formula for the parameter. The first thing you have to understand is that the formula F is the force of attraction, G is the gravitational constant, M is the mass of the body, of bigger body, the smaller M is the mass of the smaller body, while the R is the distance between the two bodies. So let's go by let's use the formula to calculate the question. According to what we have here, we have F equals to G. Now, what is the value of G? At times in some textbook it will be given, or in question it will be given that the value for G is this. So let me give you the value of G. The value of G is what now? 6.6. 6.67, or let's do 7.0. Was different textbooks use different. Okay, let's, according to this one, we have 6.67 times 10 raised by minus 11 Newton meter square per kg square. So that is the value. So we don't need to write this thing there. It looks somehow. So the mass of the bigger body, which is what? 10 raised to power 8 multiplied by what? Mass of the smaller body, 10 raised to power 3 over the distance between them is what? 2 squared. So which is what? 6.67 times 10 raised to power minus 11 times 10 raised to power what? 11 over 4. Now this cancels this mathematically. So we are going to have 6.67 over 4. Now 4 in 6, 1. So we put decimal point, then it will remain 2. Now in 26, it will be 6 times, remain 2 again, which is in 27, it will go 6 times again. Leave the remainder, so you have gotten this. Leave the remainder. Now what you calculate first, it is what? Newton. So this is the answer. Again, look at it. F equals to what? GMM over R squared. What is G? G is the gravitational constant. In some tests you see it as 7.0 times 10 to the power minus 11. But in some tests you see at 6.67 times 10 to the power minus 11. But you want to use to surely give you learning exam. Now, since you have a 6.6 times 10 to the power minus 11, that is the value of G. Then this is the value of the bigger mass. This is the value of the smaller mass. Why this is the distance between them? In indices, we have something like this. This one will give you 10 raised to the power minus 11, and this plus 11 plus 11 minus 11 is what? 0. So that's gone. That one has gone. In this case, you are left with what? 6.67 divided by what? 2 squared, which is what? 4. When you now divide it by 4, 4 is 6, remain 2. In 26, that is 6. Remain 2 again. In 27, that is another 6. So that is the answer for this question. Thank you.